Convert between symbolic statements and switching circuits. Okay, so consider the following switching circuit. Assume P is true and Q is false. Now, they also sometimes will say 1, so true is 1, false is 0, if we're dealing with some symbols. And what does that mean about the output? Okay, so when we're looking at, so is the output basically, is this going to be 1 or 0? That's the idea. Is it true or false? So think about just a real quick truth table. If I'm dealing with P and Q, we don't have to get real crazy with this. I know that P is true and Q is false. I only need this one line, right? I don't need everything because I only care about when P is true and Q is false. You'll notice that P and Q are joined by and. So that's P and Q. We have ourselves a conjunction. You know that with a conjunction, with the and statement, both P and Q must be true for that conjunction to be true. Therefore, if P is true and Q is false, the conjunction of P and Q is false. So my output is going to be a 0 or false. I know that because of my makeshift truth table down here. Okay. All right, so convert the compound statement not P or Q into a switching circuit. Assume P is false and Q is true. Determine the logical conclusion of the statement. Okay, so we start with, so I have P and I have Q. And it says assume P is false, so we'll give that a 0. Q is true, we'll give that a 1. Okay, now in our statement we have not P. So that means P goes to a not. Nots are generally given like a triangle type piece. And they're joined by the or. Okay, so we got to make it, and I kind of struggle with the or. I usually make it just a squiggly because it's not the same as the and, but I struggle. So it's joined with or, and then it goes to what? Is this a 0 or a 1? That's the question, right? So I've converted it into a switching circuit, not P or Q. So again, just like we did on the last one, let's make a makeshift truth table. So we have not P or Q. Ooh, I should get a not P in there. Hold up, wait a minute. I need to do something else. What? Not P, and then we get into not P or Q. Okay, so I know that P is false, Q is true. I love this. This is amazing. So that means not P. Well, if I take the opposite of false, that's true. So now I'm comparing not P or Q. Well, or means one of them has to be true. These are both true. So this is going to be true, which is a 1. All right, so that's how that works. Boop, boop, boop. Logical conclusion, it's true.